for Stony Brook University's Concrete Canoe team, and we'll be presenting Stony Fees. My name is Jerry Zhang, and I'm the project manager.
My name is Shuan Zhang, I'm the structural captain.
My name is Junji Kupi, and I'm the mixed design captain.
This year, our team focused on designing and constructing a concrete canoe that not only met the project specifications, but also had our push for innovative methods. Some of our key features were the refined hull, the multiple concrete mixes, as well as introducing new lightweight and more sustainable materials, and improving constructability. We'll go into more detail as the presentation continues.
Our canoe this year is designed with the goal of improving paddler comfort as well as stability and balance overall of the canoe. So to do this, we observed the performance limitations of previous year's canoes, and we realized that they mainly lacked stability, comfort, and balance, primarily due to the fact that they are asymmetric and that they are very narrow in design. So this year, we changed our design so that it is symmetric, and it also features a wider and a flat hull. And this allows for better load distribution and better initial stability, especially under 4% loading. And as you can see from our Mohr circle analysis, the maximum compression value is around 3,000 psi, and the maximum tensile value is around 450 psi. And our critical section stress circle lies well within the tangent bounds, meaning our canoe will be able to sufficiently handle the governing loads.
Alright, so the main goal for the mix design this year was to create a stronger mix compared to previous years, while also having more environmentally friendly design. This occurred by using new cementitious materials such as Type 1L and slag cement. And as you can see the results here, we have a wet unit weight for mix 1 of 96 PCF and a strength of 2940 PSI. This is the highest in the program's history. And then for mix 2, we had a much lighter mix with a final strength of 1820 PSI, which is also stronger year over year. This is the composition of the first mix. Our main course aggregate is pumice, and then our light aggregates include varying sizes of porter and cenosphere. All three of these were chosen because they are lightweight and they have high compressive strength, which helps for the end strength of the cement mix. And then for the cementitious materials, we use Type 1L and slag. Type 1L was chosen because limestone cement has a lower CO2 emissions compared to normal Portland cement, and that was one of our main goals when thinking about environmental safety. And then for slag is a byproduct of blast furnace smelting. And as a result, we try to use byproducts as much as possible so that we can recycle unwanted materials. Slag also has a high amount of silica content, which helps in the formation of CSH, which is the main binding particle in cement. Mix 2. The main difference between mix 1 and mix 2 is that there is no coarse aggregate in mix 2. All the aggregates consist of light aggregates, which greatly lowers the density while reducing the strength. This is compensated for by having a 3-layer canoe, with the first layer consisting of mix 1, and then the second and third cement layers consisting of mix 2. This will lower the total density of the canoe and allow it to be buoyant.
So during the construction process, we followed our health and safety program. We made sure to wear gloves, masks, and we also provided adequate supervision when necessary. As a part of our quality assurance and quality control program, we ensured that we tested our material, such as the compressive strength test, and this means that the canoe has its structural integrity. This is the gray bars represent our project schedule, our proposed project schedule, and the red represents any project delays. The primary reason for the large project delays this year was due to the delayed manufacturing of our mold, and also the limited lab room accessibility due to renovations. However, we accommodated for this in our project management plan, which had schedule buffers, ensuring that we would still have a timely completion. As you can see in our proposed project cost, we had approximately $68,000, and our actual project cost was approximately $39,000. There's a large discrepancy, which is also tied into our limited lab room accessibility, which resulted in us being more efficient with our time and cognizant that we had limited access. This was our final product with the aesthetics. Thank you for your time. Yeah, so there were actually hints that the lab room was going to be renovated. However, early on we had access, but we anticipated to cast before winter break, and I already had the mold ordered since the summer. But because it's such a large cost, we had to get USG grant funding, which meant that we had to apply for our asset grant, and that took a lot of time. And so we ended up casting after winter break.
What did you think about the concrete that you used with the type 1L cement? Did you notice any differences with type 1L compared to type 1 and 2?
Last year's cement last year's mix when we used normal cement, the mix design was weaker in comparison to our year's design, and this year it was similar consistency, similar workability when creating the canoe itself, and overall we saw an increase in strength, so overall it was a net plus to use type 1L.
I noticed you mentioned you used a 3-layer
Yeah.
placement of it. Is one of them more aesthetic, or are they all 3 structural?
They're all 3 structural, so it's type 1, the mix 1, and then a basalt mesh layer, and then mix 2, another basalt mesh layer, and then second layer.
Just to add on to this point, we had the 3 layers, which were, the top 2 layers were more workable, and it was for constructability purposes, because when we were sanding the material and for rower comfort, the top was a lot smoother than it's ever been.
For the 3 layers, did you do them all at the same time, or did you let it set and then do it?
We did
The
it all.
second one.
Oh, sorry. We did it all at the same time. So the way that we constructed the canoe is we had to have a certain amount of people hand mixing because we didn't have a mechanical mixer. So we allocated, let's say, half the people to mixing and the other half to patting down the concrete itself onto the canoe mold. And so what we had to do is make sure that the canoe doesn't set, because if it set for too long, we get cold welding, and then we basically have 2 separate structures rather than one complete hull.
How thick is your hull?
Let's see.
0.5-inch thickness.
Okay. So you had really thin layers of
Yeah, we
concrete.
strive to get as thin as possible.
I noticed you chose what people call female mold versus the male mold. Have any advantages or disadvantages of going with that type of mold?
Yeah, there was definitely advantages to the female mold. We've actually historically used the male mold before, but we switched over because it was reusable year after year, and on top of that, it was a lot more, it had a much smoother finish on the interior, and because we found out that we could use multiple mixes, we also had that smooth finish on top.
What was the total weight of the canoe?
It's, we didn't actually weigh it, but it's approximately 500 to 600 pounds.
Good.
Great presentation.
Thank you so much.
Thank you.